Welcome. I'm going to give a quick introduction of myself and go through some slides for some background context. And then we'll have Prem on stage here, and we're going to do a question and answer fireside chat here around some of the successes and experiences at Capital One. So with that quick introduction of myself here before I move on, I'm Joey Conway, work at NVIDIA and help build some of our deep learning software. So our team builds some of the core technologies around large language models as well as speech and how to deploy these into production environments. So for some quick background and context here, we're going to walk through a little bit of FSI background and a little bit of NVIDIA software. And then we're going to go ahead and into the fireside chat. So on the FSI side, some quick history here. Just a timeline. I think many might be familiar, but technology's been in FSI for quite a while. It's not a new thing. So you can see the history of things like ATMs and online banking, mobile banking, and then today, of course, we're going to spend a lot of time talking about generative AI. I think it is also important across the bottom to keep in mind that there are some innovations as well as challenges that FSI navigates and is able to work through. And so there's a variety. Many people experience model accuracy, explainability. Those are common challenges, cybersecurity as well. And then I think with kind of growing demand and lots of use cases and success, there might be power constraints. There's also data sovereignty, privacy. Oftentimes, this could be data needs to stay in certain geographic regions. And then, of course, there's all sorts of regulatory shifts and changes throughout the world as people work to accommodate and make sure that we're able to deploy generative AI properly. Oops. And then on the NVIDIA side, a quick overview of how NVIDIA thinks about this from the software point of view is we have what we call a data flywheel. And I think Prem will probably touch on some of this. We see this pattern where often people start with a model, but they don't realize that that's just the beginning. And so from NVIDIA, we have a software stack called Nemo, highlighted in the bottom center, that runs on AWS. The idea is that as you start with a model or some generative AI workload, you're then able to take advantage of enterprise data that could live in AWS as well, here on the right-hand side of the slide. But there's a flywheel that needs to happen that after people start interacting with the system, there's a bunch of steps that you want to take to incorporate customer feedback, customer understanding, and be able to make the system better and improve the generative AI interactions for the end users. So at the end of the day, the system is learning and growing and adapting and building new intelligence and new proprietary information that helps move your business forward. And then the last slide here on the NVIDIA side is around what we call NVIDIA AI Enterprise, which is our software suite that allows us to provide enterprise support across all of the tools that I had mentioned previously in deploying large language models, producing a data flywheel, keeping that up to date, refreshing that, and making sure it stays current for all of your latest customer interactions and changes in your business. This covers all of NVIDIA's SDKs and frameworks. It covers our new NIM, our inference microservice, and many of the existing tools and libraries you might be familiar. It runs on-prem, edge, and of course is available on AWS. And then real quick to wrap up here on FSI, just to give you a quick kind of overview, some of the general use cases or challenges we often see across banking, trading, payments. You can see a variety of things here from things like know your customer and fraud to pricing, algorithmic trading, customer service. Many of these are often common FSI use cases. Some of them, even like customer service, are quite common everywhere. But to give you the idea of kind of the place that we'll be focusing more on today. And then with that, I'll introduce Prem, and then he'll join me up here on stage. So quick introduction of Prem. He's Executive Vice President, Chief Scientist, and Head of AI at Capital One. He leads the technology, strategy, architecture, research, and development for all of their AI initiatives, as well as the data technologies at Capital One. Prior to joining Capital One, he was VP at Amazon's Alexa AI organization and EVP of Speech Language and Multimodality at Raytheon BBN Technologies. And then he's also served as Senior Vice Dean of Engineering in the UCS Verby School, as well as the Executive Director of the Information Science Institute. And he also sits on boards of partnership on AI and University of Virginia School of Data Science, is a fellow of the Institute of Electronics and Engineers, and is the author and co-author of more than 200 published papers in AI research. So with that, you can welcome Prem on stage here. All right.
That might be my,
Grab your water.
thank you. Which one? Okay, sure.
All right. Well, first of all, Prem, thanks for joining us.
Delighted to be here.
And I think if you could kind of start us off here and kind of give us a high level. I think generative AI is quite broad term, and Capital One is a very, very big business. Can you kind of start us off with how you guys think about where to focus AI? How do you kind of decide, what's important, where to get started?
Yeah, maybe we take a step back and think about the precursors for successful, development, practice of AI, deployment of AI. You showed your flywheel, Jeff. I have a flywheel with fewer nodes in the wheel, but it all starts with businesses exist to serve customers, and in the process of serving those customers, the good ones record that data because that gives you a picture about what you're doing with the customer, what are the customer's needs, etc. The better ones then use that data to derive insights into customer experiences, what might be their friction points, what are the needs that we can serve better by improving our services, etc. The best ones, of course, are looking to see where are the unmet needs. What do I learn about where my customer wants to be, and I'm not there yet? And so that's the flywheel that primes it. You improve your services, you deliver new offers, new services that increases customer engagement, more data, and this thing goes on. Now, in the new world of AI, I say new, though the world has been around for, by some measure, between 10 and 20 years in terms of AI and machine learning being in the enterprise. But you use AI to not just understand AI and machine learning, to not just understand these friction points, etc., though it does do that, and it allows you to do it at a scale that previous analytics couldn't do, because you can actually cover the entire surface area of all of your interactions to derive insights. But it also allows you to actually design and deliver those improved capabilities. So AI as an analytic is somewhat unique in that it helps you understand the friction points, but it also helps you build and deploy solutions that address those friction points or address those unmet needs. And so it kind of, if you have a flywheel and you're thinking about it as priming the pump, this thing kind of accelerates that pump. If you look at it in that context, you take your question in the context of this flywheel, then you ask yourself, what are the precursors I need to be effective at practicing AI? Well, the first thing is you need to have a great data infrastructure, right? Your data advantage is your AI advantage. And so if you don't have proprietary data, then you're bringing in off-the-shelf solutions, and you'll get the lift that you do, but it's just the lift that you can get from commodity. Though there are horizontal revolutions that are affecting all of us, like in the software development space, et cetera, truly horizontal, at least to start with. But then data. The second is the nature of your state of your tech stack. How ready is your tech stack to translate that data into technology and then to deploy that technology out there? The third ingredient is your talent. Where is your talent? And talent, I will use to say, also encompass organizational culture. What is the state of readiness culturally for understanding these models? How do you evaluate the risks of these things? How do you monitor the risks of these things, deploy them? So once you take a look at these things, then the only last factor that remains is the leverage, right? Where do you get the most leverage? And your leverage in different states of the AI journey comes from different places. For the classical machine learning journey, it's where it was in terms of your decision-making processes, et cetera. For generative AI, we are in this test and learn phase in my mind. So a lot of the leverage is about cases that have some amount of risk, but they're reasonably well understood risk, and they're on the lower end of the spectrum, but there is scale of usage, right? So you can actually test and learn from these technologies, understand their behaviors, learn the risk and management scaffolding that you need to put into place to practice them for the higher risk use cases as you slope up through the risk curve. So I think it's a combination of and each organization will have to take stock against these four things the state of your data, the readiness of your data, the state of your tech stack, state of your talent, and your willingness to acquire the new talent. And where is the leverage and which state of this evolution are you in? Then you kind of have a framework for prioritizing your use cases and going after them. And I know when it actually is at its core not more complex than this. Bringing this to life has a lot of complexity involved, and God is in the details. But at its core, this is the framework. It really is conceptually not much more complex than this.
Perfect. I think that makes sense. And as you've kind of gone about this journey, you set up the framework up front, which makes sense. It helps people know where to focus, where to invest. How have you thought about partnerships with Nvidia and with AWS along the way?
I'll tell you, so the AWS story is probably an interesting one for us. It predates me. It, in fact, starts around the time I started at Amazon, Capital One's journey with AWS. Capital One made a remarkable decision, which was to go all in on a public cloud. Right? Sometime, if I have my dates right, in 2017, Capital One may have had 15 or 16 data centers. And by the end of 2019, believe it or not, Capital One had 0 data centers. Right? And so we are all in on the cloud. We don't operate data centers. What does that give you? If you go back to the 3 or 4 things I mentioned as criteria, one is by going all in on the cloud, direct implication, all of your data, and for us, we went all in on a single public cloud. Back then, there was only one game really in town at that scale. But turns out a single public cloud gives you all the geographical resiliency, et cetera, that you need anyway. So it's not that problematic. But the immediate implication of going all in on the cloud means all of your data is in the cloud, which means it's on S3, the world's largest data store, at least at the time, probably still is. It also puts all of your data in close proximity to the world's biggest collection of compute resources that is there, which is where NVIDIA also comes in this new story, right? It also puts you on a cloud stack. We are essentially cloud natives. In terms of development, we are on a serverless journey. We are on a cloud journey. So all of our development is on the cloud, which means instantly, in kind of enterprise timescales, you have to shift all of your development expertise to kind of the most modern development stack that is in the world in order to leverage all the advantages that gives you, which means you're now you're both developing your own talent and you're bringing in new talent that is proficient at these things. Now, given that you have all of this and you have the data in close proximity and the belief that we have, which is proven out, that your proprietary data is actually the key to unlocking the value of AI for your businesses, you're now able to attract the AI ML talent that wants to come and work because they don't have to build the infrastructure. The infrastructure is there. You can actually bring business value to life. You can solve problems for your customers and for your employees, et cetera. And so this has been the framework for our partnership. Now, as we have evolved on the journey, as you know, NVIDIA itself has kind of become an increasingly important part of the AI journey, especially over the last 2-3 years, right? And so for us, the partnership with NVIDIA, of course, is about leveraging all of the wonderful silicon chips, et cetera, that you're putting out, and we're big consumers of that. But really, what we find leverage in beyond the chips is all of the software stacks that you have. And some of it is part of central to the chips themselves, whether it's CUDA and that whole ecosystem around it. But really things in NLP like Megatron or Nemo, things like that, those have been great accelerators. And even Joey, as we're building out use cases, we're a bank. We care a lot about being well managed. And for us, right from the start, we start thinking about the risks. How are we going to manage the risks? What might be the many manifestations of that risk? And to scale your ability to control risk, technology is central to it. And so things like Nemo guardrails, et cetera, have been kind of real enablers for us. So thank you for putting those things out.
Yeah, perfect. That's great. Do you think maybe in terms of like examples of places you started, could you pick an example where you think you've been kind of quick to market and then maybe one that's been more challenging along the way? And how you've kind of adapted to the challenges. I think a lot of people might get surprised by some of the, you mentioned, I think God was in the details.
Yeah. No, happy to. I mean, obviously, the first one that we kind of jumped into at scale was software development. Because if you, as I was saying, there are some things that are just horizontal. Software development, at least to start with, is one of those. I don't think the path to complete efficiency remains horizontal. Your proprietary information will start making a difference. But to start with, there's just so much leverage to be had. Capital One has a massive, Rich, our founder, who's still the CEO, likes to say, we're a tech company that runs a bank. And a long time ago at Amazon, they say we're a tech company that happens to run an e-commerce website or something. So there's a lot of similarity there. But it's reflected in the investments we make in tech. Our investments in tech, in terms of the density of investment we make, put us at the very forefront of the financial sector. In some sense, Capital One is one of the first fintechs that's out there that has actually scaled to becoming a company. So technology has been central to us. So anything that gives us leverage on the tech front, tech workforce, is huge benefit. So the first one was, of course, software authoring. And that has quickly scaled, though, to where some of the best use cases are in testing. Now, we talked about the test and learn thing. And so in software authoring, we automatically had a risk mitigation built in because any software that's developed, even by a human, goes through a review process. There's a QA process, there's code review process, testing, et cetera. So it's built to test and learn at scale with risk mitigation inherent to it, even with humans developing it. So we were able to use that. And as we found, what we found is people were starting to say, oh, I can actually start scaling up my testing with this, creating new tests, et cetera. And so just by putting it in there, we started finding that different people adopt it in different ways, and providing them that flexibility turned out to be important. The next big area of leverage is our customer support places. I mean, we're a bank, 100 million plus customers, many of whom call us every day to get answers to questions or help with things that they're doing. And so we have a large customer support workforce. And so how can we now, we know that these people are doing things as fast as they can, as best as they can, without compromising on the quality of the service they're giving to our customers. But what happens is customers have to wait for some time to get information, because this is anybody who's called into an IVR knows, right? There's this waiting period. So how do we reduce? One of the noble aims of AI in my mind is to transfer the cognitive burden from the human to the system. And so we looked at this process and said, where is the cognitive burden the most for the human in terms of, searching for data is obviously one, but turns out if anybody who uses your favorite web search engine knows, it's not always that the answer you want is the top one, especially in an ad-dominated world. There are reasons for it to not be the top one, but even otherwise, it's not organically the top one. So it turns out improving the quality of that ranking is a huge benefit for it. And why does generative AI make a difference? I'll give you an example from our everyday lives. If you were to design a system for your home that answered what are the heights of your different children in your home at different days in their life, and you train it to say, what is your height? What is Ramya's height? What is Lata's height, et cetera? And it gives you the answer. But then if you change your question and say, how tall is Ramya? Suddenly, it's the same meaning, but the words are completely different, and unless the system was trained to understand semantics instead of surface form words, it can't answer the question, even though it has the answer. Now, imagine this at scale with millions of customers asking for different things in their own different ways, but the meaning is the same. And the agent has to translate all of that and put it in. They have to think of the keywords that actually match, et cetera. So it turns out we can do a huge improvement in accuracy by using semantic. So the part of generative AI we use there is actually just the semantic interpretation piece. That gives us huge leverage. But once you have that as the foundation, now you step back and say, what are all the different back office tasks that I can use this for? and you now have a vector that allows you to slope up through those use cases. Today, more than 10,000 agents. We don't tend to put out like releases about these things, but more than 10,000 agents now have generative AI-powered solutions in their workflow, right? But they're monitored. There's a lot of observability around it, and we're constantly tracking performance, and we slope up the risk through the use cases. What are the uses we unlock is how we control the risk, but there's always the agent whose experience is improved. And if the agent's experience is improved, I promise you the customer's experience is improved. It's a happier interaction. Happy agent leads to a happy customer interaction, and you reduce the cognitive burden on the agent, you improve the experience for the user. There are many other use cases. There's fraud and et cetera. You asked about the hard one. It's not necessarily hard in just numerical. There's aspects of fundamental technological hardness to this use case, which is credit. But I'd say the real thing there is building up the scaffolding so that you can do it in a way that is well managed, that is compliant with the law, et cetera. So we have a lot of strategic patience there. We will use all of these other use cases to understand the behaviors of these models, build up the supporting tooling and scaffolding required to practice it in these other areas. So if you look out into the future at destination, is it going to be used in some of these things? Yes. Are we in a rush to get there? No.
That makes sense. I wanted to touch real quick. You mentioned on guardrails early on. So I'll spend a minute and talk about it, and then I'd love for you to say more, because I think as we notice, especially enterprises going to production with generative AI, guardrails, which NVIDIA has Nemo guardrails, which is an open source SDK, and we're working on a microservice, which allows you to direct and constrain the topics, the security and the safety content of what comes into the system, as well as what the system produces going back out. And we often find a lot of people might not think about designing this early enough in the process, and it's often something that comes up at the end. Can you say a little bit about how you thought, because you mentioned thinking about risks in the system.
Yeah.
How did you guys go about incorporating this?
Yeah, so on the guardrails, specifically with Nemo, and there might be one or two other open source things, so we integrate a bunch of them, but Nemo is certainly one of the key ones that we use. Take a standard use case like one in which there's potentially customer interaction in the end. And there are places we're working on them, like, for example, if people are looking for which car to buy, and it's not a fundamentally risky transaction, because you're not dealing with finances, you're not dealing with proprietary information. These are databases that the dealers may have with car availability, et cetera, and people are logging in. Go to the Capital One app, you'll know what I'm talking about, but there's a place where you can go do car shopping, right? And then it leads you into your auto loan experience, et cetera. When you look at experiences like that, the risks you're worried about are kind of like, is it going to stay on topic, right? Or if people are asking for certain things, what kind of responses might it generate? Even though we don't, even on that front, everything is human in the loop. We don't necessarily allow the answers to just go straight to any end user. It goes through human review, and then there's a click through and send. But you still have to build in guardrails so that people don't make a mistake. And so is the output appropriate? So on the input side, is there a jailbreaking prompt there somewhere, et cetera? And when you start looking at it, and then on the output side, is it appropriate content? Is it safe content, et cetera? So these are all the things. And what we love about Nemo and some of the other open source things is how much we can configure them. We can configure them for our use cases. We can optimize them with our data on the topic side, et cetera. And these things provide progressive layers of security. And on the input side, you can imagine in a world where eventually you have automation of at least some of these things, that thing has a little bit of a cyber aspect to it on the jailbreaking prompts, et cetera. So for those, and as you know in cyber, you collect information from around the world to keep up-to-date track of the latest kind of threats and threat vectors, et cetera. So it's really hard for any single entity to do all of that harvesting. So having somebody, in this case, NVIDIA, keeping track of it, updating these guardrails. So the guardrails are not a static thing. They're also not a thing that you just configure by yourself. There's also world knowledge that comes into the guardrails, which is why we love having these offerings. Greatly simplifies our work and gives much better protection to everyone.
Perfect. That makes sense. You mentioned in terms of use cases, one that was kind of easy and horizontal was more around software development across the company. And we've done the same thing at NVIDIA. We published a paper and built a model called Chip Nemo, which we use to help do architecture design on chips because it was important to our business. And as we went on that journey, we learned a lot about what models could and couldn't do, how capable they were, and how to keep humans in the loop, as you mentioned. Can you share kind of your experience? Like, what do you think have been the big gains from it and the big advantages or learnings that have come out of this software development work that you guys have done for quite a while now?
Yeah. The Chip Nemo thing, from what I understand, is actually kind of not so much directly about chip design as it is about knowledge sharing and knowledge assistance.
Yes.
And so I'll say when you start building this framework out, and developers are also, a big part of their job is knowledge sharing, and any of you who are still deeply involved in software development probably know there's a lot of tribal knowledge in these systems or in these groups and in these operations. So how do you unlock this knowledge at scale? How do you make it self-service? How do you allow people to contribute what they know? And once they contribute, once a piece of information is shared once, how do you automatically institutionalize that information so that it's available to everyone? So those are many of our learnings. We also, for example, note that one of the modalities people like a lot is actually the chat modality in software development, more than the inline. Now, I'm sure there are people who prefer inline, so making all of these available to everyone is useful. But the chat modality allows people to interact a little bit more and also get more context about it along with the code, and also provide more context. So all of that. So our observation is that knowledge sharing piece of it, which is another really important area of work for us, looking out into the future, is key, which is very similar to the Chip Nemo thing.
Perfect. And I think we've seen the same thing on the Chip Nemo side, and I know even myself, just being able to paste a stack trace of an error message into a chat and then have a conversation about it can be quite helpful. There's a lot of resources that you can learn where experienced people on the team know a bunch more, and they've been able to distill that knowledge into the system that maybe newer people can gain from much quicker. That makes sense. I'm curious if you could maybe talk to us about some of the kind of key or fundamental challenges you've ran into along the way. Like, what have been things either you expected or any of the surprises along the way that you didn't expect to challenge there that you've had to work through?
I think one challenge, maybe it wasn't that much of a surprise given the context I came in from, but one that I find that people run into all the time is you take a press release as if it was a developer blog, right?
Okay.
And people expect the performance to be something out of the box when they download something, and it turns out it's not. Yeah. And so to the extent that there is a trough of disillusionment with this thing, you can see sometimes that expectations are set so high when people just read about this and they have passing knowledge of this, that the moment they first test it and they say, oh my God, it fails on these things. That's where, so one of the things I found is this set of expectations and what understanding in general organizations have about the state of readiness and what it takes together. The thing is, these are amazingly plastic technologies and elastic technologies. They can learn a lot, they can consume a lot, they can be configured a lot, they can be quickly optimized for things. But that requires both understanding of the technology and availability of the data and understanding of the domain and the application that you're doing, right? So it requires this ability to mobilize across the company. So I'll say on the next level, the first is kind of what people's expectations. The second thing I'll say is how important it is to mobilize across the company and across the enterprise, many different functions, and this is where company culture comes in and what you incentivize, how much is collaboration and inclusion incentivized in our culture. They're all, in my mind, differentiators for you. So that was the second part. I was very pleased with how we were able to mobilize across the company, bring different functions together. Even a simple application you'd be surprised, takes dozens of people across many different functions. This is not like a year-long effort. It might just be a month or a month and a half or 2 months. But in that time, the amount of mobilization across many different functions, types of expertise, lines of business, et cetera, that you need to do was interesting to me. We're all used to the world of siloed development and deployment of AI, right? You have your data, you build a model, it predicts some scores, you use it in your decision-making thing. But these things that lift everything across just require so much more mobilization across the company. Third thing is, I'd say, I wasn't surprised with the amount of interest we had across the company early on. I have been surprised with how that interest has sustained itself and shows no sign of fading. So we are a very platform-centric company, and we build platforms, and the whole company uses those platforms. Our tech enterprise tends to be very centralized in that way. And as we build those platforms, we've seen, early on we built sandbox in there for people to experiment with, and the demand for that sandbox is along with features in that sandbox. So tremendous amount of experimentation, and how people there's so much hunger to use any kind of experimentation resources, that people use that to surface use cases, to validate use cases, and to come with really well-developed things. So I've also found there's just so much creativity. This is kind of democratized kind of the development of many new ideas, if you will.
Yeah, that's great. That makes sense. I'm curious, in maybe the last one you mentioned, I've had the opportunity to talk to a few different people across FSI, and this idea of having experimentation and sandboxing and maybe pulling things off the internet that are just new and recent but might not have been as thoroughly vetted. How do you guys at Capital One approach this? Because you mentioned all the interest and the sustained interest over time. How do you kind of harness that for the benefit and help everyone work together on it?
There's no such thing at Capital One, I hope so, at any financial company, of just pulling stuff down from the internet that has not been thoroughly vetted, just to make it clear. We do have a fair amount of processes. I mean, this whole notion of being well-managed and well-controlled from a technology and other process perspective is core to our existence, because the consequences of not doing that are bad. They're bad for your customers, which is the main reason you shouldn't do them. But they're also bad for the business, because the regulators will put all kinds of constraints on you if you don't show that you're well-managed and that you practice your well-managed philosophy well. So for us, we actually, one of the areas in which we worked very closely with our risk and compliance partners was in developing a scaffolding for governance around AI that was not initially it was centralized, and we formed a bunch of central teams, central councils, et cetera. But then it's been federated out quickly in terms of fair amount of the governance being federated out into the LOB teams, et cetera. And that is a trend that will continue. But no, even if you take a new model, there's a bunch of tests it has to go through, external benchmark tests, internal benchmark tests, fair number of other governance processes it has to go through. Even if it is an updated version of a model that you already have, like maybe your favorite model released version 2 and now they're releasing version 2.5 or 3. Yeah, you still have to go through a lot of those things and scale it through. Turns out, again, your data is important, your data act is important, your talent is important, and your ability to institutionalize these processes is important. How do you control your model inventory? How do you track your performance on these tests? Do you have a record of the last test that you ran? Can you quickly compare with these? These are all things that are good things to do in a startup or in the tech world. These are absolutely necessary things to do in our world. And so we invest a lot in that kind of.
That makes sense. You mentioned a bit along the way of being able to take models or use cases and to test and evaluate them. How do you think about kind of this evaluation methodology or framework, or how central or rigorous is this?
It has to be a part of the platform. And I wouldn't say that we are awesome at it quite yet, but it has to be part of the platform, and it has to be the thing that I don't think we're as awesome as we can be eventually, is how low friction it is for people who want to run those tests, right? But the important thing is to make sure that it's platformized and that the process is repeatable, right? And that you're providing a place to run those benchmarks and to record the performances so that it can be inspected by all the equities in your company, compliance, audit, et cetera, that need to inspect those things and share their perspectives on your test results. So I think that's a journey that will continue in terms of improving the experience of the everyday lived experience of our data scientists and our applied researchers and all of those. But it's all part of the platform. There's a fair amount of training that goes, people training, in terms of how to construct test sets, how to run tests, what metrics make sense, how to measure those metrics. Old adage in science that has worked well for me is if an improvement looks too good to be true, really 99 out of 100 times it's not true, right? But you need to have the rigor to be able to inspect it, or maybe the test set made its way into training, things like that. They happen innocently enough, but they happen. So rigor is super important in these things. Most of the times when you find out your offline tests are not good predictors of online tests, two things have happened. One is your offline tests were too old and they didn't reflect the new distribution, or somehow your offline tests were optimized against by the model without you realizing it, right? So do you have the rigor of doing limited online tests to validate your offline tests every now and then? All of these things matter, and those are the kinds of things that we provide as a platform to everyone. We also build, on the foundation models, what we've found is customizing. This is an extension of your proprietary data. Your data advantage is your AI advantage. We've found that customizing these models make the difference between being able to take some use cases to production versus not. Right? So that's also super important for us.
Yeah, that makes sense. I think on the Nemo side, we've also started trying to publish some best practices on how to measure things. I think another adage we use is, if you can't measure it, then it's hard to keep improving it. And
yes.
So with generative AI, it's producing new content you haven't seen before. It also becomes a challenge of how do you need to go measure it.
Yeah, it's not just, it's if you can't measure it, but also the data act comes back again, in that if your platform is not instrumented to store all of this information. In my mind, it's okay to make a mistake once. Maybe it's okay to make the same mistake twice. It's really not a good idea to keep making the same mistake. But unless you've recorded those mistakes, those transactions, those interactions with the users, you actually can't learn from them to improve them. So all of that becomes part of your, a critical part of your strategy.
That makes sense. You mentioned data strategy in general. And can you say a little bit more around how you think about that, from customizing models to evaluating them?
Yeah. So for the longest time, there's been a focus on the volume of data being a key differentiator of performance. One of the things we're discovering, especially with Gen AI and transformers, because of the detail at which they learn and model the relationships in data, is that the quality of the data, both in terms of its completeness and its just cleanliness in general, its consistency, et cetera, is super important. Because these things can anchor on small variations if they're systematic. It's really important to make sure your data is very high quality. So we've found that, and it's not just us, I think if you look at the literature in this area right now, you will find that that investing in data quality has a massive payoff, which then leads you to think about it in the context of your overall system. What does it mean? How do I scale data quality? And a lot of it has to come from fair amount of automation in everything that you do. So it puts you on a particular pathway of thinking architecturally in terms of how you ensure it. It also means that your investments in data really pay off. Like, if you have a technology that learns from data, and it learns much better from higher quality data, this is a great place to be for organizations that are willing to take the long-term view and invest in making sure you have lots of data and lots of good data. And so we're finding those also, we're validating those in our own experiments and in our own use cases. But this is actually a lesson that's out there broadly in the literature, if you look at it today, in terms of the quality of data being important. This is why you find a lot of organizations now creating their own instruction following data sets and all of that, even though in principle, all of the out-of-the-box, state-of-the-art models are doing a lot of it.
Yeah, that makes sense. We've done the same thing as well too, and I think in our chip Nemo example, we actually did our own instruction following small segment just to teach it in specific scenarios how our developers want to interact. Because as you mentioned, kind of generally they're great, but specifically you want them to be working very well with your kind of data, your use cases, and your domains. Can you say a little bit more about the customization? I think it was great that you mentioned that you found some use cases without customization, they're just not there, but you've been able to customize, and that kind of bump in accuracy or outcome or improvement was sufficient. You were excited, you could then go and deploy it. Like, how have you approached customization, and kind of how have you gotten ready for it? How do you measure it? How do you manage that?
It's a strange learning, right? In the sense that if not for the fact that out of the box these things are so impressive in a generalist sense, you wouldn't have forgotten the fact that the entire history of AI and machine learning is custom models, right? So pre-ChatGPT, you built custom models with custom data for custom users. 98% of all the models in the world are supervised machine learning models as of like 2 years ago. But then suddenly the advent of this thing made you feel like I have a general purpose thing that will solve everything. And what we're finding is that there is a happy medium, that this provides a much better starting point than anything that you ever had before, but that the addition of your data makes a crucial difference between the performance that you want to deploy. And you want to put your company's reputation behind it and your tech quality standards behind it. And so you do want to have a certain level of conviction. We have found, what are the many different forms of customization? They go all the way from continuous pre-training to, supervised fine-tuning to, parameter-efficient fine-tuning, things like LoRa, QLoRa, et cetera, prompt engineering, all of that. And we are finding lift in all of these. It just depends on how much data you have for a use case and what is the performance required for that use case. And we're finding each one of these gives us lift.
Perfect. That makes sense. In the Nemo software stack, we support all those varieties from pre-training, which isn't always as common, to the continuous fine-tuning, to some of the PEF techniques like LoRa as well. Yeah. So it's great you're seeing lift across all of these techniques.
Yeah, and especially on instruction following, every organization, some of your cultural processes, the way in which you want to present yourself to a customer, et cetera, are all things of practice that just vary from one organization to another, not because of any fundamental reason, but that's kind of your identity. And so those kinds of things are about, especially as you do more interactions with customers, you want to invest in those things because that's how you're representing yourself to your customer base.
That makes sense. You've in other contexts, I've heard you mention something that I thought was a great insight, where you said something along the lines of, deployment is the beginning, it's not the end. And I think there's a lot of experience that goes behind that statement. Can you share a little bit around why you say that and kind of what that means?
Yeah. I think the way I put it was, deployment is the first step on your stairway to AI heaven, right? Yeah. And the other steps are called post-deployment monitoring, observability, tuning, continuous improvement, and things like that. And that's because your first two things happen. One is you have a certain amount of data. You don't want to wait for too long to develop these models in their final form and send it. You want to get to a threshold of performance where it is useful to either your employees or to your end customer. So you deploy it. The other thing is people's interaction with these technologies actually changes with the improvement in these technologies. So it's not that the data that is used to train these things and improve these things is a static concept. Because as you improve these things, the way people interact with them, so people no longer, when you're talking with something, you may use like staccato keywords or you talk in a particular way, and you find it's responding to you in more natural language. You start saying more and more natural things, and then you start expecting bigger things. And so you start expressing yourself in different ways. Long time ago in AI, we called it anthropomorphic confusion, in the sense that people don't, and this was the Turing test, if you will, like if a system behaves with you like you're talking to a human, is it human or not? Can you tell the difference? It's a version of it. But people do start expecting more and more from the system. For the first time, we have a technological base that allows us to keep feeding these bigger and bigger expectations. But the other reason why I think of it as a lot of the action, if not most of the action, is post-deployment, is because there is that Heisenberg thing. Until people start interacting with it, you don't know how they will interact with it, what they will expect with it, what they want from it. That data becomes crucial in improving your performance. And so basically you inject a change into the world, and the state of the world changes, which means the data on that world changes, which means you want to bring that new world into your model. And that loop continues. That's not a flywheel necessarily, that's just a loop that keeps happening, and you want to keep improving it.
Yeah, that makes sense. Can you say a little bit, kind of going throughout this process, we've talked about like data strategies, acquiring data, we've talked about customization techniques and the benefits you've seen across different use cases. We've now talked about deployment, and then that's actually the beginning. There's lots of work that happens after deployment, and we've talked about guardrailing. Can you say a little bit around how you think about, say, like explainability and governance as you go through this process and you cover all these teams and all these workloads? How do you have kind of either from a cultural or a process or maybe both kind of point of view of ingraining this throughout?
Yeah, I mean, look, in financial services, what are the different entities at the table? Right. There is, first of all, to understand, maybe some people here are from financial services, we have this whole model of first line, second line, third line. In the first line are people like me developing the technology, building up the solutions, architecting, designing them. But we are expected to embody a sense of responsibility around it and have good practices, et cetera. And what makes it so that we don't just say that and not do it? It's because there's a second line that is your constant partner that has a bit of a review functionality to make sure you're doing this right? But then you can ask the same question: why doesn't the first line just pay off the second line, and why doesn't it become because there is a third line that's an audit function that reports directly to the board that comes and inspects you and asks the second line, show me how you're effectively challenging the first line, right? And so they have to do that. And why do all of this work? They're all still part of the same company. It's because at a minimum on a quarterly basis, the government regulators show up at your doorstep and tell me how all of you three lines are working properly and challenging each other and holding the bar up. So in the financial services, there's a fair bit of regulatory scaffolding that makes this all work. That has created a culture of where things are documented and there's a lot of training and people. So first thing to keep in mind is that there's a lot of stuff there. It also is manifested in the form of institutions within our companies. Like we actually have a model risk office, right? That is supposed to evaluate all of the models and give their own assessment of the usability of these models for different use cases, right? Now, so when I was in the tech industry and even in academia, these were all kind of in principle thoughts we had, like how would you do it? Coming to financial services, I've realized, my God, there's actually a way to practice this. Now, I don't think it directly scales to take this to every kind of industry, but in it is the seed of a concept that I think can be scaled in terms of how to have effective challenges within your own companies, et cetera. And I think the smart companies, even if you're not in a regulated industry right now, will start creating some of these scaffolding themselves so that they're ready for the inevitable coming of some of these everywhere. And the rest will do it when they have to.
Yeah, perfect. I think that makes sense. It's definitely something people should have in mind as they go into the experience. Maybe the last question I'll ask here, and then we can open it up to the audience for a few questions. As you kind of look forward, and there's lots of new technologies coming, I think we see a lot around like copilots, agentic workflows. As you kind of look forward, what are some of the things you're most excited about? And what do you think is going to kind of impact your business or have the most change coming?
So one, of course, you already touched upon it, is the agentic workflows, which is really the next layer of capabilities on top of these models, right? How can I execute actual tasks, whether in partnership with humans or entirely autonomously over time? So agentic workflows are big. We are making an investment in them. We are developing out our own frameworks, et cetera. Agentic workflows are also a place where business process and business understanding and domain expertise meets technology, because you're doing some heavy lifting with these agents. It also requires an ability to bring your data into your models, because these agents need to be proficient at specific tasks, because agents are actually specialists in a particular task. And maybe a simple-minded agent understands your query, a second agent does some planning, a third agent actually finds the right things to look up to answer your questions. Maybe there's another agent that validates all of your answers. So in agents, you can just imagine how you're going to break up your complex workflow into pieces that can be executed separately, and how these models are configured for. That's one. I also think one of the areas that we're going to see a lot of progress in is inference optimization. Many of us are focused, there's a lot of focus on the cost of training these models, and of course, it's hugely expensive. But the ongoing cost is really that of running these models, and inference costs are big. One of the surprising untold stories, in a way, is that inference costs on an equivalent performance basis have gone down not 1 order of magnitude, not 2 orders of magnitude, but 3 orders of magnitude in the last 20 months. And when I say order of magnitude, I still live in the decimal world, not in the binary world. So this is like 10 to the power 3, not 2 to the power 3, which I find some of the younger generation, like for them, the order of magnitude is binary, which makes sense too. But it's 1,000. So in this environment of like such rapidly decreasing costs, it makes no sense to make ROI decisions based on today's costs or things like that. So you kind of have to place a bet on like where things are going. But I think that's going to be another area. A third area is actually likely the progress in the game theoretic or reasoning style capabilities that we're seeing emerge, where the performance on verifiable problems improves quite a bit. Like, general natural language interactions are not really verifiable problems, but take some puzzle or some logic puzzle, et cetera. So the fact that model training is shifting from training for word prediction to trajectories and logic chains, I think that's another direction I'm super excited by.
Perfect. That's great. We also love the inference optimization space at NVIDIA. So.
Of course, I mean, we're counting on you to do a lot there, but we're not counting only on you.
Yeah.
But we're counting on you heavily to do a lot there. Yeah.
That's great. All right. I think that's it for our time. So thank you, Prem. Thanks, everyone.
Thank you all.